So we're going to learn about scientific investigation, which is how you do an experiment in science. Sometimes people think that a science
Something happened.
experiment, okay, a lot of people think that when you do a science experiment, it's just grabbing random stuff around your house and you put it all together and then you see what happens. That's not how we do a science experiment, or at least not how we do a correct science experiment. So we're going to take a look at this video here. And the video is going to go through the different steps of how to do a science experiment or scientific investigation correctly. So let's click here. Before we start the video, make sure that in the Google call that you go, or the Google Meet, that you go ahead and turn off your cameras. That way everyone can see the video a little bit better. So make sure your mics are muted. Make sure that your cameras are off. All right, we've got almost everyone with their mics off and their cameras off. Okay. Okay. Let's take a look at this video.
Have you ever had a question about the world? Like what plants need to grow? Or how to blow bigger bubbles? There is a way to find the answer to these and other questions that is used by scientists. It is called the scientific method. If you use it, you can be a scientist too. The scientific method is a way to ask and answer scientific questions by making observations and doing experiments. There are 6 simple steps to follow. First, ask a question or identify the problem you would like to solve. Second, make observations and do research about your topic. Observation means to study carefully. Once you have observed and researched your problem, you are ready for step 3. Form a hypothesis. A hypothesis is an educated guess about how something works. In order to be useful, a hypothesis needs to be testable. This means that you can actually test it and see whether it is true or not. After you have your hypothesis, move on to step 4. Design an experiment and test your hypothesis. When designing an experiment, you must be sure to only test one thing at once. You can do this by making sure to only change one thing or variable in each experiment.
I'm going to pause it there for just a second. That is very, very important for a scientific investigation, for a science experiment, if it's done correctly. You can only change one thing at a time. If you change multiple things at the same time, then you can't really tell what it was that made something different. And we'll talk a little bit more. We'll get more specific with an investigation after we finish the video.
Everything else must remain the same. Once you have completed your experiment, analyze your data. To do this, you will look at the results of your experiment and try to figure out what it means. Finally, using your data, you can draw a conclusion. If your conclusion did not support or agree with your hypothesis, that's okay. It doesn't mean it was a bad experiment. Using the information from your first experiment, you may need to form a new hypothesis and create a new experiment to test it. Even if your conclusion does support your hypothesis, you may have a new question you'd like to test and can begin the scientific process all over again. The scientific method is a step-by-step way to solve problems and answer questions logically. Thanks to the scientific method, many important discoveries have been made about our world, but many unanswered questions remain. Would you like to help answer them? You can. Just remember to be scientific. Ask a question, make observations, form a hypothesis, design an experiment and test that hypothesis, analyze your data, and draw a conclusion.
So in our science notebook, we have some notes here about scientific investigation, and they even talk about an example experiment, something that we might actually do. Okay? So, scientific investigation is how a scientist answers a question that they have. And like it says here, how do they answer the questions they have? Well, they investigate. They see what is happening. So it all starts off by asking a question. They'll see something or they'll notice something, and then they wonder, well, why is that? It doesn't just happen because something has to make it happen that way. All right. So first they always start off with the question. Why is this happening? Once they have a question, they'll usually come up with a guess. That guess in science is called a hypothesis. Okay, and let me zoom in here. That way it's a little bit easier to see. So we have an example. They might see two different cars. In this case, they have a Camaro and an Impala they're looking at. And they might think to themselves, I wonder which of those cars is faster, the Camaro or the Impala? And then they'll have an idea, a hypothesis. Well, just looking at them, I think the Impala is going to be the faster one. Okay, so after they have this question, and after they come up with their hypothesis, then they plan a test. The test has to be a fair test. Okay? So in this case, since they're just trying to figure out which car is faster, I say maybe I should have the cars race on a track. Again, the test has to be fair. So you couldn't say, okay, well, I'll have the cars race on a street that's all bumpy and torn up. Because that wouldn't be fair. If one side is more messed up than the other, then one car is probably going to win. And since they're having a race, it has to be a fair race, right? The same way that if you were running a race against somebody, you can't start on the start line and they can start in front of you. You have to start side by side. Otherwise, it's not fair, right? Then one person would have a better chance of winning. So once they're sure that they have a test that's fair, that they know is right and it's going to work, they start to gather their equipment or any tools that they need for it. So in this case, they would need the cars because they can't race the cars without cars. They would need a racetrack somewhere for them to drive. They would need some drivers. They would need a timer and maybe a camera. Why do you think they would need the timer and the camera for? Because the drivers have to be there for the cars. The cars, that's what we're testing. The racetrack is where they're racing, but why do they need the timer and the camera? Why do you think those would be important? Bailey, what do you think?
I think it's because so they know how fast a car goes and are the winner, I guess.
So if it's a timer, it won't tell them how fast it's going, but you're right. It'll tell them how long did it take them. So if it's really, really close, then they can look at the times and see what's different. Why do you think they need the camera for? What's the camera for? Kylie, what's the camera for?
It's like when you're going to the line, who crosses the line first.
Okay, because if it's really, really close and the two cars are just about to pass the line about the same time, If they have a camera, they can take a picture and they can see which car actually crossed the line first and which one crossed the line second. Okay, then this is important. They gather and organize the information. Now, when we're talking about a science experiment, we call that data. So it says here, okay, I'm going to time the races and write down all the times in this chart. Then it says, I need to have a few races to be fair. Why do you think it says that they need to have a few races? Why can't they just have one race and that's it? What do you think, Messiah? Why couldn't they just have one race and then that's it?
Because if they're racing in cars, they're trying to see which car is faster. So they race. You didn't see that. So they race until to see who gets the most race, to see which car is faster.
Perfect. So they have to race more than once because if, let's say, one of the drivers makes a mistake and they lose, the car didn't lose because it was slower. The car lost because the driver made a mistake. So if they have just one race and one of the drivers makes a mistake, well, then we don't really know if the other car is actually slower or if it was just the driver's fault. The same way that if you were racing someone and you tripped and you fell and you didn't win, would that be a fair race? No, because you don't know if the other person was really faster than you or just, I made a mistake and I lost because of that. So they want to have more than one race. And Messiah brought up a really good point. As they have more and more races, they can look and see, okay, this car, how many times did it win? And the other car, how many times did that one win? And that's actually the next step. After you finish your test, they look at the data and they try to see a pattern. So a pattern is like when we talked about our multiplication with the 2's earlier. If you can see the same thing happening over and over and over again. So it says here that when we're talking about a scientific investigation, that we call that analyzing the data. It means looking at it and trying to see something that keeps happening over and over again. It says, it looks like the Camaro won 37 races and the Impala won 13 races. So what's the pattern there? Who can tell me what's the pattern in those races? What do they keep seeing over and over again? Nakai, what's the pattern they would see there?
That's one won 37 races, one won 13 races, and Camaro and Impala.
Okay, so they raced the cars and they saw that the Camaro won 37 times and the Impala won 13 times. So which car is winning more of the races? Kaylee?
Carmo.
So the Camaro's winning more of the races, right? So if we look and see, okay, the Camaro's usually winning. So which car's probably the faster car? Messiah, which car would probably be the faster one?
The Camaro.
The Camaro would probably be the faster one. Because even though it didn't win every single time, it did win a lot more than the Impala did. Now, back to their point about only changing one thing at a time. They only had 2 cars, right? They only had one racetrack, and they only had 2 drivers. They never talked about changing the drivers, or changing the racetrack, or getting a new car. The only thing that they're doing is they're keeping everything the same so they can really see, is this car faster than this other one? If they start trying to add in new cars or new drivers, or they start having the races in different places, then it's kind of hard for them to say, oh, well, it's just the car that's different. So after they look and if they can find a pattern, then they can make an inference. So in a scientific investigation, that's called a conclusion. So that's like their answer. And once they have their answer, they can make a prediction. They can kind of figure out what's going to happen in the future. So just like you guys did, they came to the conclusion, it looks like the Camaro won the most races, so it's the faster car. So that's their conclusion. The Camaro is faster. But then they can make a prediction. So if they keep racing, the Camaro will probably win. Now, we can't say it'll win every single time because the Impala did win some of the time. But probably, it will probably win. This is something that people kind of get wrong when they're thinking about like science experiments and scientific investigations. Even if your hypothesis is wrong, that doesn't mean that your experiment was bad, or that, you know, you failed the experiment, or that it was a terrible experiment. Because remember, the hypothesis is just a guess. If you guess all the time, are you going to be right every single time? No, because it's just a guess. A guess isn't always going to be right. Sometimes it is, and sometimes it's not. So even if you were wrong with your hypothesis, you can still learn something, and sometimes that'll even give scientists even more questions. So in this case, it says, I guess I was wrong about the Camaro, but I wonder if it will beat a Ferrari. So now they're already thinking, okay, if it was faster than this car, is it faster than this other car? If they were going to do this experiment again to see if it was faster than the Ferrari, what would they have to change? Bailey, what would they have to change if they were going to do the experiment again with the Ferrari?
The racers? Or the racer?
The racers, like the drivers, they don't have to change, but they would have to change the car. Because the same racer could just drive a different car, couldn't they?
Yeah.
Yeah. So they could even keep the same drivers and just, instead of driving the Camaro and the Impala, drive a Camaro and then a Ferrari. That way only one thing changed. The drivers didn't change. The racetrack didn't change. The camera, the timer didn't change. The only thing that changed is the car. They only changed one thing. If you change too many things at once, then again, it's kind of hard to figure out, well, what made that happen then? Was it the different car? Was it the different driver? Was it the different racetrack? What made the difference? Oh, hold on. That was a little bit ahead. We're not quite there yet. So, what do you guys think? First, give me a show. People like to skip some of these. One of the things that people don't like to do is they don't like this part. They don't like having to do the same experiment over and over and over again. They think if I do it once, that's it. To be fair and to give you really good information, you can't just test it once. You have to test it more than one time.